Question 1. Gina correctly stared to answer the following question. Complete her solution. So the question is, solve the following equation for all real values of theta. Express your answer in radians correct to 3 decimal places. 3 sine squared theta minus 14 sine theta minus 5 equals 0. So it looks like Gina stared at her solution. She only got one step in, but it looks like she correctly factored the expression, because it states she correctly started to answer. So I guess the factoring is correct, and other than that, we need to continue on. So because this is factoring, it saves us the step of factoring, but remember, quadratic trig equations must equal 0, and it does, so she factored it correctly. So we're going to solve each factor. So if we solve 3 sine theta plus 1 equal to 0, sine theta is going to equal minus 1/3. We brought the 1 over, subtracted 1 from both sides, then we divided by 3. I'll do the other part to this. Sine theta minus 5 equals 0. Sine theta equals 5. So notice this is a calculator question, and at this point we have to use our calculator. When we're using our calculator to find the reference angle, we never put in a negative ratio because the negative tells us the quadrants we're in. So this is the symbol I use for a reference angle, and it's sine, inverse sine of 1 over 3. So when we do this on my calculator that I'm using, I need to go shift sine. On some other calculators it might be second function sine, but you go inverse sine, and then in brackets go 1 divided by 3, and I get a reference angle of 0.3398. 3398. And you know what, I'll go keep the 4 there as well, around that. So this is our reference angle. If you're not getting this answer, you want to make sure your calculator's in radians, okay? So make sure it indicates that on somewhere on your calculator screen. The next part now is to determine the quadrants. So sine is negative. So where's sine negative? Sine is negative. Well, if we think about all students take calculus, sine is positive in quadrant 1 and quadrant 2, so sine is negative in 3 and 4. So in order to get our quadrant 3 solution for theta, we would want to go pi plus my reference angle, so 0.3398. So on my calculator, I'm just going to add pi to the answer that's on there, just so that I don't make any rounding errors. And I'll state my answer to 3 places as it asks. So I get a theta value of 3.481. And again, that's rounded correctly, and it is in the 3rd quadrant. My quadrant 4 solution, right, to the end of quadrant 4 is 2 pi. So it's 2 pi minus my reference angle of 0.3398. So I'll put that into my calculator. 2 pi minus my reference angle of 0.33984. And to 3 decimal places, I get 5.943. All right, so here we have 2 solutions for the first part. The second part is much easier, much quicker, I guess, but we want to state it. If you think of the sine graph, sine oscillates between -1 and +1 if you think of the sine curve. So it will never reach a y value of 5. So this part has no solution. Okay. So I think we're almost done here. Let's read the question one more time. Solve the following for all real values. Okay, so they want all real values. So that's a fancy way of saying general solution. So when I state the general solution, I want to add multiples of my period. So my period for sine is 2 pi. So here's how I'm going to write my solution. My final answer, my general solution, sorry, is 3.481 plus 2k pi, where k is an integer. And some people use z for integer. Some people use n for your integer symbol, but that should be fine. And my other solution to 3 decimal places is 5.943 plus 2k pi, where k is an integer. So let's circle these solutions, and I think we're done.